Dear learner, welcome to my YouTube channel, Dr. Israel Classes. And in today class or in today video, I will show you what is the PN junction or what is the PN junction diode and what is the depletion layer and how it exists between the P-type and N-type semiconductors. So in my previous video, I have discussed, which I have uploaded on this channel also, the details of p-type semiconductor and n-type semiconductor. But let me remind here, the p-type semiconductor are the semiconductor in which the majority charge carrier are positive holes, and in n-type semiconductor the majority charge carriers are negative electrons. That is why we call them on the basis of nature of the majority charge carrier, p-type and n-type semiconductor. So as I told you that in p-type semiconductor the majority charge carrier are holes, which is represented here by hollow circle or empty circle, uh, and in n-type semiconductor the majority charge carrier are electron, which is represented here by the dots. So the boundary between the two different kind of semiconductor is the junction, or is the junction between the two different kind of semiconductor. So let us put p-type semiconductor on one side and n-type semiconductor on another side, and the junction between them is called pn junction. So what happened actually, ideally nothing happened, but practically something happened when the junction is made between these two semiconductors. So due to the thermal agitation, the majority charge carriers diffuse to n side. That means the positive uh, holes will diffuse to the n side, and the positive vacancies will be here. Positive holes will be here. They will diffuse to the n side because of thermal agitation, and the minus charge carrier or negative charge carrier will diffuse to the p side. So here with equal to the positive charge carrier which is diffused to n side, there are minus charge carrier diffused to p side here. So there is a region near the boundary. So this is the boundary, this is the pn junction, and this region in which the charge carrier diffuse near the boundary, it depend upon the conditions. That means it depend on the energy given to the pn junction. It can extend or it can reduce, but ideally due to the thermal agitation, this is the region near the boundary, and this region is called depletion layer. So this is about the pn junction, and because of this thermal agitation, this region is made here, and this region is called depletion layer. So let us talk about the forward biasing and reverse biasing of the pn junction. So this is, we can say, this pn junction diode. So what is forward and reverse biasing here? Let us discuss here. So I'm gonna show you here the forward biasing of pn junction. So it forward biasing and reverse biasing is nothing. Another is reverse biasing here. So it is nothing. It is the criteria of the connection of pn junction to the external battery. So here, what is forward biasing? When you put pn junction in such a way that the p-type semiconductor is connected to the positive terminal of the battery, and n-type semiconductor is connected to the negative terminal of the battery. So this combination, or this circuit connection of the pn junction is called the forward biasing mode of the pn junction. On the other hand, let us talk about the reverse biasing here. So reverse biasing, we will do opposite connection to the forward biasing. Let's say this is the P and N type semiconductor. So let us connect P type semiconductor with negative terminal of the battery, and N type semiconductor, let us connect it to the positive terminal of the battery, and this combination is called the reverse biasing. So the forward biasing, in which we connect P type semiconductor with the positive terminal of the external battery, and this is positive, this is negative, and in reverse biasing we connect the P type semiconductor with negative terminal of the battery and N type with the positive terminal of the battery. So now in my next video I will show you the working of PN junction diode in forward biasing and reverse biasing mode. I hope you enjoy this video. Thank you for watching, and for the next information you can click on my next video, which is going to upload here very soon. Thank you.